Next, I wanted to talk about, well, what if the equation has fractions or decimals or more difficult types of numbers in them? And strategically, everything is exactly the same. There's just a few other tricks that we can do to make the equation easier if we want. So if we don't like fractions, we can get rid of them and not have to deal with them. But technically, you don't have to. So let's look at an example, like say for example, this one right here, 7/8 x times x plus 1/4 is equal to 3/4 times x. And again, what we might notice here is that we have two different variable terms. So what I want to do is get them both on the same side. And you could do that, but one thing that is, usually I'd recommend is if you want to just get rid of the fractions, we can get rid of the fractions to simplify the types of numbers that we're dealing with. And to get rid of fractions, we can always multiply by the LCD, which is short for least common denominator or lowest common denominator, which is basically after looking at all the denominators, which is just the word for the bottom of the fraction. We would want to know, well, how do I multiply each one of those to cancel them? So there's a process for finding it, which involves taking all the common factors and doing all that. But in this particular case, it would be 8, because 8 times 8 would be 1. 8 divided by 8 would be 1. 8 divided by 4 would be 2. And 8 divided by 4 would be 2. Basically, it's the lowest number that would cancel them all out upon division. You can technically use a larger number, but you always use the lowest because it'll leave you with the smallest coefficients. So in this case, basically what I would want to do is multiply. Sorry, my tablet is going crazy here. I'm trying to do the math here on my tablet. But I would want to multiply both sides by 8. And basically, when you something to review about the multiplicative property of equality is that when you're multiplying both sides of an equation out, you need to make sure you're multiplying every term of that equation, not just one term, which is a little different. It's not different than the additive property of equality, because if I was to just start off and say I wanted to subtract 1/4 from both sides, I wouldn't need to do it to every little thing. But when you are multiplying, because if I'm multiplying the whole left-hand side and the whole right-hand side, you need to still use the distributive property, and that's a step that a lot of students forget about. So careful there. But basically, I need to multiply everything by 8. Or, another way I could write that would just be like this. I would put an 8 here, 8 times here, and an 8 times there, which is basically meaning 8 is multiplying in each of those fractions. And remember, when you're multiplying a whole number into a fraction, it always multiplies into the numerator of the fraction. But in the case when 8 matches the denominator, 8 divided by 8 is just 1, so I can just cancel those out. This would leave me with 7x. But when it comes to 8 times 1/4, well, 8 times 1 is 8, so this is just 8 over 4, which is indeed 2. And then 8 times 3/4, what I could do is I could do 8 times 3 is 24 divided by 4 is 6, or I could do 8 divided by 4 first, which is 2. 2 times 3 is 6 as well. But that would leave me with 6x. And again, if fractions aren't your favorite thing, your calculator can actually do fractions. This is something not everybody knows about. Say you wanted to do 8 times 3/4, 8 multiplied by alpha F1 is where you can find the fraction menu. If you just hit enter, you can insert a little fraction like that. So anyways, if fractions aren't your strong suit and you're a little rusty on your fraction, I would recommend reviewing those things for for your basic arithmetic. But anyways, cool. And this is why multiplying by the LCD is nice, because if I multiply through everything by 8, it will get rid of all the fractions. Now I've just reduced my equation down to whole numbers only. And now I could reuse the strategy where I put all the variable terms on one side and all the constants on the other. And since, well, there is only one constant term, usually what I would do is I would leave that one alone, and I would subtract the 7x to the other side. That would leave me with 2 is equal to negative 1x, or just negative x. And last little thing about, remember, if there is a coefficient, and you can write the 1 if you want, or you don't have to, because 1x is a singular x, so the 1 is redundant, it's not really necessary. But just to recall that when you have solved for x, you want it to be all by itself, so you don't want the negative either. And just as a reminder, to get rid of a negative, there's a number of ways you can do it. Some professors will say divide by -1, or you can multiply both sides by -1, or another property of an equation is you're allowed to what we call negate both sides of the equation, which just take the whole equation and change all of the signs of every term. So if I were to do that, I could change the left-hand side to a negative and change the right-hand side to a positive, and that would leave me with 1x, or x, is equal to -2, the correct answer in this particular case. But that's the same thing as if I were to divide both sides by negative or multiply by negative, which I just refer as negating the equation. But reverting back to the original equation and my original point is that you can just use a traditional, you don't have to use what we call the LCD method there. You could just use the more basic property of equations to solve this instead. So I'll move over here to the left-hand side. And this is something that I like to do a lot, is I like to show you guys a lot of different ways to think about the same thing. And you might be wondering, well, why? If I know the answer and if I know how to do it, why would I want to change it up and do something different? But this is what algebra is all about. There's a lot of different strategies. Sometimes one might be a lot easier than the other. And that's just kind of up to you. You have options, you have tools at your disposal. The thing that I want to focus on, what are those tools and why? That's another big thing about my lectures. I like to focus on, why do these things make sense, and why am I doing this? Why am I allowed to do this, and why does it make sense? Because I don't like to just teach you guys, okay, I do like to teach you the steps and how to do them, but without the cognition of and the recognition of the reasoning, all is lost in math. And I do not like math instruction without the why. Now, answering why is often harder, but to me, it's why it's interesting and is why I really enjoy what I do. But anyways, going back to this question, you can technically solve this equation without using the LCD method. You can just do the normal method, and well, I have 7/8 x on the left-hand side and 3/4 x on the right-hand side, and I have a numerical term all by itself. So instead, I could just subtract 7/8 x from both sides of the equation, because 7/8 x minus 7/8 x will make 0x. And that will leave me with just 1/4. And then what I would have is, well, 3/4 minus 7/8 x combine like terms because they're both x's, so I would add, or in this case, subtract the coefficients, 3/4 minus 7/8. And so 3/4, well, to subtract 7/8, I need a common denominator, which would be 8. So multiply this by 2, that would leave me with 6/8 minus 7/8, which would be -1/8 x. Or as I was saying, you could just do this in your calculator by using alpha F1 and just doing fractions. So 3/4 minus 7/8. And you do, or I could just use the normal fraction bar like this, is fine as well. But if you type in the values without fractions, it will express your answer as a non-fraction, as a decimal instead. So if you wanted to specifically get fraction answers here, you would want to use fractions in both cases, 3/4 minus 7/8. And the answer should be in the same numerical type that you typed it in. But when you use the slash bar for your division, which is the division symbol, which is when you type it in, it looks like this, it will give you a decimal, because like how the calculator thinks here is that this symbol means actually divide and give you the decimal answer. These symbols mean, okay, work with just fractions and give me the answer as a fraction. But anyways, we're still not done though, because I'm still trying to solve for x. So the next step would be, well, I have 1/4 is equal to -1/8 x. And now to cancel out a fraction, I want to multiply by the reciprocal. So as I said before, to cancel out 1/8, I multiply by 8/1, or 8. And to cancel out a negative, I would need to multiply again by a negative. So if I multiply both sides by -8, I'm just going to use parentheses to make sure to imply that I'm multiplying here. -1/8 would cancel with -8, which would leave me with just x. And -8 times 1/4 would be -2. And again, I'm going to get the same answer. So this is why we usually use the LCD method, because doing all the fraction math for most people is more of a headache. So why don't we just multiply through by the common denominator? And that will remove the fractions, and then I can focus on the gist of the equation without having to worry about the fractions.